Hello everyone, my name is Atish and topic of this learning video is Cayley-Hamilton theorem. As you know that in the last learning video we have started this topic, and if you remember, what is the statement of Cayley-Hamilton theorem? The Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. Okay, so for the Cayley-Hamilton theorem you must have a matrix to be a square matrix. Okay. In this learning video, we are going to start by taking an example of 3 by 3 matrix. In the last learning video, we have taken a matrix of order 2. Here, we will take an example on 3 by 3 matrix. Okay, and as far as the working rule is concerned, so what was the working rule? So, as I stated in the earlier video also, that in the working rule of the Cayley-Hamilton theorem, step number 1 and step number 2 remains the same. What is step number 1? Step number 1 says write or find the characteristic equation, and then step number 2 is apply. What is it? Apply Cayley-Hamilton theorem. Okay, so these were the two steps which is common for all the example throughout this topic. Okay, and the third and four steps depends on the type of problem. In the last problem we have to verify, that's why the third step is verification step, and the fourth one is we have to reduce the given polynomial into a linear polynomial, that is the result. Okay, so these are the steps under working rule. So first two steps remains the same, where the third and fourth step will vary according to the problem. Okay, so without much ado, let us take a problem on this topic. So let me write down it. I am writing down the question as example. Find a power minus 2 when a is equal to 201, 111, 102. So this is the matrix we have, and we have to find out a to the power minus 2. Not just this, and hence find the matrix, represented by a to the power 8 minus 5a to the power 7 plus 7a to the power 6 minus 3a to the power 5 plus a to the power 4 minus 5a cube plus 8a square minus 2a plus r. Okay, so as you can see, again we have the two parts in the problem. The first problem is to find a to the power minus 2, and the second part is you have to find the matrix represented by this matrix. Okay, so let us start with this. So the very first thing that you have to do in this is you can write down the given matrix. Let A is equal to this, and then what is the first step? Write down or find out the characteristic equation. Okay, so do you remember what is the characteristic equation for the matrix A? The characteristic equation is determinant of A minus lambda I is equal to 0. Is it? Now try to write down this matrix, which is, you can write it as, that is determinant of, what is it? 2 minus lambda, 0, 1, then 1, 1 minus lambda, 1, 1, 0, 2. is equal to 0. Okay, so we have written this matrix A minus lambda I within the determinant. Okay, now this is the matrix of order 3. So we will be getting characteristic equation of order 3. Okay, so characteristic equation would be a cubic one. So let us write down the equation. Lambda cube minus S1 lambda plus S2 lambda minus determinant of A is equal to 0, and say this is to be equation number 1. Okay, now what I am going to do is I am going to find out S1, S2 and determinant. Okay, what is S1? You know now, you are very smart now. What is S1? S1 is the trace of the matrix, right? So let us find out S1. So what is S1? S1 is equal to trace of the matrix. Trace of matrix. And what is the trace of the matrix? S1 is equal to trace of the matrix, which is sum of the diagonal element 2 plus 1 plus 2. So what is it? S1 is equal to 5. What is S2? S2 is sum of the minors of the diagonal elements. So what is it? S2 is equal to sum of the minors of the diagonal element. So what is the minor of this diagonal element? Minor of this is remove this row, this column and take the determinant of remaining. So this is 1, 1, 0, 2. What about the minor of this element? Delete this row, this column, you get 2, 1, 1, 2. 2, 1, 1, 2. Okay, now what would be the minor of this element 2? Minor of this element 2 is delete this row, this column and take the determinant of remaining element, that is 2, 0, 1, 1. Now try to write down what is it? 1 into 2, 2 minus 0. So 2 plus 2 2s are 4 minus 1, 3 plus 2 1s are 2. So what is it? 2, 2, 4, 3, 7. So we get S2 to be 7. Okay. Now we got S1, we got S2. What we need to find now? We just need to find out determinant. Okay. Can you able to find out the determinant? We can find out determinant. I am writing here. This is 7 and determinant of A. What is the determinant of this? Can you able to find out the determinant? You can make use of calculator or you can solve manually. Okay, so determinant, let me write down the determinant here. I will doing some rough work. Determinant of A is equal to 2 into 2, 2 minus 0, minus 1 into 0, plus 1 into minus. Okay, so what is it? 4 minus 0 minus 1. So 3. So we got determinant to be 3. Simple. So determinant of A is equal to 3. I have found this determinant manually. You can go with just find out with the help of calculator also. Okay, so just substitute all these values where we want to substitute all these values in this equation. Okay, so what will be getting? We will be getting equation 1 as lambda cube as it is minus what is S1? S1 is 5 lambda square. Then what is S2? S2 is 7 plus 7 lambda minus what is determinant 3 equal to 0. So here completes my equation number. Say this is to be equation number 1 and this completes my step number 1. Now what you need to do is you just need to apply the Cayley-Hamilton theorem for the second step. Okay. So for second step what should I need to do? Therefore by Cayley-Hamilton theorem what we need to do? We just substitute lambda is equal to A because What is Cayley-Hamilton theorem? Every square matrix satisfies characteristic equation. So this is the characteristic equation. Matrix A will satisfy it, means put lambda is equal to A. So we get A cube minus 5A square plus 7A minus 3 times I is equal to 0. Say this is to be equation number 2. Okay. Now if you remember what we need to find out, we need to find out A power minus 2, right? Let me clear this. So we have A cube minus 5A square plus 7A minus 3i. This is equation 2. Now to find A power minus 2. So how one can find out A power minus 2? You just find out A inverse and then take a square of A. It would give you A power minus 2. Okay. So our objective for the time being is to find out A inverse. Okay, so let me write down this equation nicely. So what I will do is I will take 3i on one side and rest of the value on the other side. A cube minus 5a square plus 7a and minus 3a to the left is plus 3a. Okay, now multiply this equation. Multiply, as this matrix has determinant non-zero, so I can multiply by A inverse on both sides, so what we get when you multiply both sides by A inverse, I will be getting 3 into I into A inverse, so A inverse, A cube into A inverse, so it is like A cube into A inverse. Okay, so this is like A cube minus 1, so this is A2. Okay, so likewise we can write directly this A cube into A inverse is A power 2 minus 5A plus 7. A into A inverse is I. If you want, you can give here reason A into A inverse is equal to I. Okay. Now what we need to do is we just need to substitute the values and get the answer. Therefore A inverse is equal to 1 by 3 times. For the time being, I will write it as 3A inverse. What is matrix A? Do you remember the matrix A? Okay, what was matrix A? 2, 0, 1. I just forget the matrix, so let me write it down. 1, 1, 1, 1, 0, 2. Matrix A into, writing A square as A into A. So again write 2, 0, 1, 1, 1, 1, 1, 0, 2. Okay, minus 5 times A. What is A? 2, 0, 1, 1, 1, 1, 1, 0, 2. Okay, plus 7 times I. What is I? I is an identity matrix of order 3. Why? Because A is of order 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now solve this. When you solve this, what will be getting? 2 2s are 4, 0, 1, 5. So this is 5. Then this row, this column, 2, 1, 1, 4. Then 2, 0, 2, 4, 2, 2, 4. Then multiply this, 2, 0, 0, 0. Then 0, 1, 0, 0. And then 2, 2, 4. Then 1, 1, 2, 4. Then 1, 0, 4, 5. So we got this is to be A square minus 5 into this. What is it? 10. 5 5, then 0 5 0, then 5 5 10, plus the last one 7 0 0 0 7 0 0 0 7. Okay, now just add. When you add, you'll be getting a matrix. So this is 3A inverse. Therefore, A inverse is equal to 1 by 3. Now solve this to get matrix. What is it? 5 minus 10, 7. 5 plus 7 is 12. 12 minus 10 is 2. Okay? Is it 2? Then 4, 5, 9. So let me write down it. 9. Not 4. This is 4 minus 5. 4 minus 5 is 1. Writing very far. So 1. Then 4 minus 5 minus 1 minus 1. Okay. Then 0 0 0. So let me write it. 0. 1 minus 5 is minus 4 plus 7. 3 minus 4 plus 7 is 3. 0 0 0, and then 4 minus 5 is minus 1. 4 minus 5 is again minus 1. 5 12 2. So I am getting A inverse. I am getting the value of A inverse as 2 minus 1 1 0 3 0 minus 1 minus 1 and 2. Okay, so this is nothing but A inverse. But do we need A inverse? No, we wanted to find A inverse, A power minus 2. So what you can write is, just to save some space, I am writing here. Therefore, A power minus 2 is A inverse square. So just take a square of it. Okay. So what is it? This is nothing but. So let me write this in the next line to make it more clear. So we have to find out A power minus 2. So what is it? A inverse square. So what is the square of this? 1 by 9. And how to find out the square of this? Don't tell me like 2 square minus 1 square minus 1 square. It is not the case. Okay, what you have to do is, you just have to multiply this equation with the same equation. 2 minus 1 minus 1 0 3 0 minus 1 2 into again the same matrix 2 minus 1 0 3 0 minus 1 2. Okay, so what is A power minus 2? Therefore, A power minus 2 is 1 by 9 times multiply. What is it? 2 2s are 4, 0 plus 1. So this is 5. 2 1s are minus 2, 2 into minus 1 minus 2 minus 3 plus 1 minus 2 minus, okay. So this is like minus 2 minus 3 plus 1, okay, minus 4. Then this is minus 2 0 minus 2 minus 4, then 0 0 0, then 0 3 3s are 9, and then 0 0 0 0. Now this row, this column. Okay, so if you get confused when how to find out multiplication, just with the pencil you can make this arrow. First row, first column, first row, second column. Okay, likewise. Now we are doing this. Third row, first column. So what is it? Minus 2, minus 2, minus 4. Okay, then this one, 1, minus 3, minus 2. 1, minus 3, minus 2. Again minus 4, and then minus 1 into minus 1, 0. Sorry, minus 1 into minus 1 plus 1, then 0 and 4. So I am getting this. Okay. So what is a power minus 2? A power minus 2 is 5 minus 4 minus 4, 0, 9, 0 and minus 4 minus 4, 5. This is just the first part. So if you want, you can write hence first part. This is just the first part. Now we have to go for the second part. What second part says? In the second part you are given a big polynomial of degree 8 and you have to reduce that polynomial. Okay, actually you have to find out the matrix represented by that polynomial. So let me write down the part 2. So part 2 says you are express the matrix represented by what is it? A to the power 8. Let me write down the question. A to the power 8 minus 5a to the power 7 plus 7a to the power 6 minus 3a to the power 5 plus a to the power 4 minus 5a cubed plus 8a squared minus 2a plus I. So this is the matrix we have: a to the power 8 minus 5a to the power 7, 7a to the power 6 minus 3a to the power 5, a to the power 4, 5a cubed, 8a squared minus 2a plus I. Okay, now what we have to do is we have to express, or we have to find the matrix, not just express, find the matrix represented by this. So what we are going to do, see, you can find out a to the power 8, a to the power 7, a to the power 6, higher order matrices. That is a very time consuming task. So what you can do is you can apply Cayley-Hamilton theorem, reduce this polynomial to the polynomial of degree less than as much as you can make it a small degree, and then apply the, and then you can do the calculations to get the answer. Okay, so to reduce this polynomial into lower degree, what we need to do is we need to divide this polynomial by the equation number 2. So let me write it again: a to the power 8 minus 5a to the power 7 plus 7a to the power 6 minus 3a to the power 5 plus a to the power 4 minus 5a cubed plus 8a squared minus 2a plus I. Okay, and we have the, from the Cayley-Hamilton theorem, we have the characteristic equation satisfied by matrix A. What was that? A cubed minus 5a squared plus 7a minus 3I. Is it? Okay, a cube minus 5a square plus 7a minus 3i. Okay, now here it is a power 8 and we have a power 3. So we need to multiply this equation by a to the power 5. To get a to the power 8, we need to multiply this equation by a to the power 5. So what will be getting? A to the power 8 minus 5 a to the power 7 plus 7 a to the power 6 minus 3a to the power 5. Okay, now there will be a change in sign. So there will be change in sign, like this is minus plus minus plus. Okay, now as you can see, a to the power 8 get cancelled with this get cancelled, this also get cancelled. Wow, that's so nice. All these things get cancelled, so we remain with a simple one, that is a to the power 4. I am writing here a to the power 4 minus 5a cubed plus 8a squared minus 2a plus I. Okay, now we have this equation. Now we have a polynomial of degree. What is it? We have a polynomial of degree 3 and we want a power 4. So a power 4 can be found out by multiplying this by a. So let us multiply it by a. So what will be getting? A power 4 minus 5a cube plus 7a square minus 2 a power 4, 5a cube, 7a square, 3a, right? Minus 3a. Again there will be change in sign, minus, plus, minus, plus. Okay, so again this get cancelled. This again get cancelled. Now here you can see plus 8 minus 7, 1a square, minus 2 plus 3 is plus 1a, and this I as it is. Okay, so as you can see that we have the remainder, degree of the remainder less than the degree of this. Okay, so no further, what we can say, no further division is possible. Okay, so write down this equation. So therefore this can be equal to, now see here I am writing this as a to the power 5 times a cube minus 5a square plus 7a minus 3i, then plus a times a cube minus 5a square plus 7a minus 3i, and at last the remainder. What is the remainder? The remainder is a square plus a plus I. But if you remember, this is my equation number 2, and what does equation number 2 says? A cube minus 5a square plus 7a minus 3i equal to 0. Is it? So from equation 2, this is a to the power 5 into 0 plus a into 0 plus a square plus a plus I. You can give here reason by equation 2. Okay, so we have a big polynomial of degree 8 and we reduce it to just a square plus a plus I. Okay, that is the beauty of Cayley-Hamilton theorem. Okay, now you have a square, you have a, you have I. Just substitute and get the answer. So what is a square? A square we have found out actually. Okay, by doing the calculations we have found out a square. So what is a square? Do you remember? 5 4 4 0 9 0, something like 5 4 4 0 9 0, no, 5 4 4 0 1 0, and then 4 4 5 4 4 5. So this was a square we have found out. Okay, in the second part we have just found out. Plus a, what was a? Matrix A, matrix A is 2 1 1. Let me write down the given matrix from the question. 2 1 1 0 1 0 and 1 1 2. Okay, so this was the matrix. And plus identity, simple, 1 0 0 0 1 0 and 0 0 1. Okay, so now you can calculate. So this comes out to be, what is it? 5 plus 2 plus 1, 7 4 5 4 5, 4 plus 1 5. Next 0 0 0, so 0 1 1 1 3 0 0 0, then 4 plus 1 5, 4 plus 1 5, 5 plus 2 plus 1, that is 8. 5 5 8. Okay, so in this way we just got the value 8550. This is 8. I have written 7. 5 plus 2 plus 1, that's 8. Okay, so 855030 5 5 and 8. Okay, so in this lecture we have seen how you can make use of Cayley-Hamilton theorem to solve such type of problem, and not just inverse but the power of inverse also can be found out. Okay, so I hope this is making sense, and just go through the video carefully. If you have any doubt, you can contact me. Okay, so thank you for watching this learning video. Thank you.